Can you guys also see the screen?
Yeah.
Yeah.
Looks visible.
Okay. Yeah, so hi everyone. Today we'll discuss a question similar to assignment number 6. So, yeah, uh, is anyone saying something? Okay. Yeah. So, does anyone have any doubts from the last class? Yeah, sorry. Hello.
We can hear you.
Can you guys hear me? Hello.
Yes, we can hear you, sir.
Yeah. Yeah. Okay. Yeah. So we'll get started. Yeah. So the first question is 60 patients visit the outpatient ward in a hospital every day, 8-hour time period. On a particular day, in the first 2.5 hours, no one came. What is the probability for that? Use exponential distribution. So, given that in total there is 8-hour time period where the ward is open, and there are 60 patients that visit the ward. So the average time between each patient will be 8 by 60. Uh, yeah, because 8 hours is the time and 60 number of people come. So we expect them to be evenly distributed. So it'll be 8 by 60. Uh, then this mean time between patients uh, is the value of our mu. Is the average of the exponential distribution. Then we need to calculate the rate parameter for the exponential distribution, which is given by 1 by mu, which is 60 by 8, which is 7.5. Now we need to find the probability that on a particular day, the first 2.5 hours, no one came. So for the exponential distribution, we know the probability of x being greater than equal to small x is given by e to the power minus lambda uh, small x minus lambda into small x. So substituting 2.5 for x, which gives us the probability that the first patient, like the time difference between the patients is at least 2.5 hours. So someone came at least after the first 2.5 hours. So we substitute x equal to 2.5 in this equation, and we get e to the power minus 7.5 into 2.5, which turns out to be 7.19 into 10 power minus 9. Is that clear?
Yes, sir.
So moving on, the second question is the heartbeat of 10 mice treated with drug A are as follows. So we are given 10 values of the heartbeat of mice that are treated with drug A, whereas the heartbeat of drug B treated mice are given as follows. And then we are again given 10 more values. If we use the Mann-Whitney or Wilcoxon rank sum test, what is the rank sum of drug A treated mice? So for this test, first what we need to do is we need to arrange all the numbers that we have for drug A and drug B in an increasing order. Then we assign ranks to each of those based on the increasing order. And then for drug A, we get all the ranks for all the values. And then we add them to get the rank sum of drug A rated mice. So first what we do is we first arrange them in increasing order, all the values, all the 20 values. Then for each value, we assign a rank. So here, since both of the values are similar, we don't assign a rank directly. Okay. But what we do is we give them both the average rank. That is, for the first one, the rank is 1. For the second one, the rank is 2. So the average rank will be 1 plus 2 by 2, which is 1.5. So both of them will have a ranking of 1.5. And the third value has a rank of 3, fourth has a rank of 5. Again, for fifth and sixth, we do the same. We take the average, which is 5.5, and so on. We calculate the ranks for all the 20 numbers that we have. Then what we do is we know the values for the mice that are treated with drug A. We get the respective ranks from this ranking table. And then we just add all of the ranks to arrive at the value of 77. So the rank sum here is 77. Is that clear?
Yes.
Yeah. So the third question is with reference
Yeah,
to,
question.
yeah,
Could you just go back to the problem itself? The-
this one.
This one. What
Yeah.
is the rank? Oh, only drug A is asked. Okay. Okay.
Sorry?
No, I just wanted to read the problem once more. They have asked only for rank sum of drug A. Okay. I thought
Yeah.
they had asked for both, which is significant. I mean, is there a significant difference between the two or something like that?
No, no, no.
Only, okay. Yeah.
Yeah. The
No
question
problem.
is just the rank sum for drug A treated
Drug A.
mice.
Okay. Then,
Yeah. Then the third question is with reference to problem 2, what is the rank sum of drug B treated mice? So again, we have this table, the ranking table. What we do is for drug B, we know the values. We get the ranking from the ranking table, and we just add all of them to arrive at the value of 133. So the rank sum for drug B treated mice is 133. Is that clear?
yeah.
So the fourth question is the logarithmic bacterial colony count in the blood on 13 patients before and after vancomycin injection is given below. Use Wilcoxon signed rank test to choose one of these options. So option A is antibiotic injection has no effect on reducing the bacterial cell count. Option B is antibiotic injection has an effect on reducing the bacterial cell count. Option C is cannot conclude, and option D is both data are the same. So for each patient, before the treatment, we are given the bacterial colony count in blood, and after treatment, we are given the bacterial colony count in blood. So here our H naught or null hypothesis is there is no difference. That is, the antibiotic injection has no effect on the bacterial colony count. And our alternative hypothesis here is antibiotic
எனக்கு கரெக்ட்
injection.
ஆகிட்டு போடு.
ஏய் நம்ம ஏன் பேக்குறீங்க சாரி
Yeah, that's it. Yeah. The
I did
alternative, yes. Sorry.
sorry
Yeah,
sir,
you
I
can.
didn't realize my mic was on.
Yeah, that's okay. Yeah. So here the alternative hypothesis is antibiotic injection has an effect on treatment. So since we are just detecting an effect and we don't know about the direction of the effect, we'll do a two-tailed test in this case. So first, what we need to do is we list out the table, the before treatment and after treatment values. Then we calculate the difference. So here what we have done is before minus after. So here we have just calculated the difference in each of these points. So this is 11.53 minus 9.96, which is 1.57, and 11.32 minus 10.8, which is 0.52, and so on. We get all the values. Then we assign a signed rank to all these values. So for example, like this is the lowest value. So we need to arrange them in an increasing order and then assign ranks. So since the lowest value here is 0.08, we assign it a rank of 1. The next greater value is 0.19. So we are just looking at the absolute values here. We are not looking at the positive and negatives. Okay. Since the absolute value of minus 0.17 is greater than 0.08 and it is the second greatest value, we assign it a rank of 2. But since the sign here is negative, we assign it a sign of 2. So the signed rank here will be minus 2. And then so on 3, 4, minus 5, 6, 7, and we assign all the ranks till 13. Then what we do is we get the sum of all the positive ranks, which is given by adding all the positive numbers here, which turns out to be 84. Then we also get the sum of all the negative ranks. So here we just have two negative ranks, that is minus 2 and minus 5. So adding both of them up, we get 7. Here we discard the sign the sign is needed just to differentiate between the positive and negative ranks. While taking the sum, we don't need the sign. Then for the Wilcoxon signed rank test, we use the smaller value of both of these. So for the positive ranks, the value turns out to be, sum turns out to be 84. For the negative ranks, it turns out to be 7. So the minimum of 84 and 7 will be 7. So we take the value to be 7, the t value to be 7, the test statistic. Here, since there are 13 patients, n is given as 13. Then what we need to do is we need to look at the table for two-tailed test for n equal to 13. We'll see the values at both alpha 0.01 and alpha 0.05 because we are not given a significance level. So at for the two-tailed test with n equal to 13, alpha 0.05, we get a critical value of 17. And for alpha 0.01, we get a critical value of 9. The value that we calculated, the test statistic that we calculated is 7. Since our test statistic is lower than the critical value for both alpha equal to 0.05 and alpha equal to 0.01, we say that there is a significant difference and we have basis to reject the null hypothesis. So the option that we'll choose here will be P, antibiotic injection has an effect on reducing the bacterial cell count. Is that clear?
Just the portion after the calculation where you summed up the positive and negative ranks, just that portion,
Yeah.
if you could just display. Yeah. So T is equal to 7, N, okay, that is the total number is 13. Okay, fine. Yeah.
So
And
we are
based on
not,
that,
sorry.
yeah, I know, I just missed that a little bit. The T equals 7. That is a sum of the negative ranks and the lower of the two numbers we are taking. Yeah.
Yeah. So we what we do is we assign ranks. While assigning ranks, we take the absolute values of all of these to assign ranks. Then we take, like, if there's a negative sign in the difference, we just make the rank to be minus of whatever it is. Yeah. Then we take all the positive ranks and sum them up. We take all the negative ranks and sum them up.
Yeah.
Then for the test statistic, what we do is we choose the minimum of both of these values. So 84 and 7, the minimum value here is 7. Therefore, our test statistic is 7.
And then the table, if you could just display to the next page.
Yeah. For the table, we just look
13.
up at n equal to 13 for both alpha equal to 0.05 and alpha equal to 0.01.
Okay.
Unlike the other tests, the other parametric tests and all we have done, where, like, what we do is we get a value from the table and we check if our value is greater than that value. Here in Wilcoxon signed rank test and man-Whitney test, these non-parametric tests, what we do is we check if the t value that we get is less than or equal to the critical value. So if it's less than or equal to the critical value, then it is a significant difference. Then we can reject the null hypothesis.
We could face a scenario where it falls between one-tailed and two-tailed kind of scenario like we faced earlier.
It's the same thing. It depends on what you define. So here we have defined, here we have defined that there is an effect and there is no effect. So we are basically doing a two-tailed test. Yeah.
So here for subtraction, can we reverse the columns?
Sorry? For subtraction. Yeah. For subtraction, you can reverse the columns. So
are you getting my
what
question,
will happen? Yeah, you are asking if we can reverse the column, like subtract this value from this. So this value from this.
Subtract means subtract 11.9.
Yeah, we'll get the same result.
Okay.
So for example, if we subtract the opposite way, the first value here will be minus 1.57. This will be minus 0.52. This will be 0.17 and so on. So the values won't change because we are still subtracting the same numbers. Only the sign will change. So this will become minus, minus, plus, minus, minus, plus, minus, minus. Rest of them will be minus. Then
So
the
let's-
ranks, sorry.
So let's say, suppose we were to get the sum of negative ranks in all these as the higher, let's say minus 84, it might come as, let's say, and you get the, no, okay, there the sign doesn't matter. Okay, yeah, okay,
Yeah, so
yeah. No.
basically what will happen here is like if we subtract after from before, sorry, before from after, you will get just these signs. These values won't change. So again, while you are assigning ranks, you will assign the same ranks because you're just looking at absolute values. The only difference in this column will be that this will be -6, this will be -3, this will be +2, this is -1, -13, and so on. And then what will happen is for the positive ranks, you will just have 2 and 5, and you will get a value of 7. And for negative ranks, you will add all these other numbers and you will get a value of 84. But again, here what we are doing is we are taking the minimum of both the values. So again, the t value that we'll get is will again be 7.
Yes, yes.
Does that answer your question?
Thank you, sir.
Yeah. It does not matter what you
Sir,
subtract. Yeah. Yeah,
hello.
yeah, continue.
Sir, how to find sign rank value, sir? Please explain.
Yeah, so here what we are doing is we got the difference. There's 1.57, 0.52, minus 0.17. Disregard these values that I just wrote. These are for another expansion. Yeah. So here what we'll do is we'll arrange them in ascending order. So for example, the first value will be 0.08. The second value will be 0.17. The third value will be 0.52. Fourth one will be 0.72. And so on till 4.72. Right. We are just looking at the absolute values of these differences. Then we'll assign ranks to each of these values. So the first one will be 1, the second one will be 2, 3, 4, and so on till 13. After that, what we need to do is, here we see that 0.17 is negative. So we assign the rank to a negative sign. Similarly, for the fifth value, we have a negative sign. So the rank will be -5. So this is how you get the signed rank. Is that clear?
Okay, sir. Thank you, sir.
Yeah.
Hello, sir.
Yeah.
When we go for two-tail test and one-tail test, depends on hypothesis formulation.
Yeah, it depends on your hypothesis.
Right now, in the earlier problem in the lecture, they have asked only two-tail test.
Yeah.
At 95% confidence interval and also at 99% confidence interval.
And
the
the
same
question,
problem, I think. 7, we get 7, and it is compared at 95% for n equal to 13, and also at 99%.
Which one are you talking about?
In the professor's video problem.
Okay. Yeah.
They have used for both the confidence intervals.
Yeah, so it depends on what the question is and what hypothesis you are formulating based on the question. Here we are just looking to see if there is a difference, if there is an effect of the antibiotic. So we are doing a two-tail test. If we look at if you want to check if the effect is positive or negative, then we'll do a one-tail test.
Okay. Right now, in the sign rank test, we'll compare the t value. If it is less than the table value, then we reject. That's what, right?
Yeah, if it's less than or equal to the t value, then we reject.
In other normal like F test,
Yeah,
T test, and all,
it's all the opposite.
why we take opposite here?
That's how these non-parametric tests work, basically. So what they are doing is like they want to see if your minimum value is small enough to reject. Another way to go about it is like if we get a maximum value, like here we are getting the minimum value and we are seeing if it's less than a given value. Another way to go about would be to check the maximum value and to build a table for that and see if it's greater than the other value, greater than the critical value. But I don't know why they prefer this minimum method. There might be some reasoning for this.
Because in t-test, z-test and all, will take greater
Yeah.
than symbol to reject.
In all the
null hypothesis.
parametric tests, we take greater than.
Only
in the
in the
non-parametric
non-parametric will
test, we
take less
leave.
than.
Huh.
Any
Most of the
non-parametric test will
non-parametric
take less
tests.
than, sir. Whether it may
Most
be
of them,
Kruskal
yeah.
values or Man-Whitney test.
Whatever you are taught, like Wilcoxon and the other Man-Whitney U test and everywhere, you take less than.
Okay, sir. Okay.
Yeah.
And when we take, when we reject magnitude, when we take only sign, which test there is?
So yeah,
there are
so
two
in the
types, right? In sign.
Wilcoxon sign rank test, we take the sign into consideration. In Man-Whitney U test, we don't take the sign into consideration.
Okay.
Yeah, we just take the absolute values.
No, in some in some test, I think we'll take both magnitude and rank both together.
This is the one where we take magnitude and rank.
Sign rank test.
Sign rank test.
Okay. In Man-Whitney, only will take sign.
Man-Whitney only will take magnitude. There's another one where we only take the sign. And we use a binomial distribution to see if the number of positives is greater than expected value.
The sign test.
Sign test. Yeah.
Sign test. Okay.
Yeah.
Sir, can you explain the difference between exponential distribution and
Explain the
difference between exponential distribution and Poisson distribution?
exponential distribution and Poisson. Okay, so Poisson distribution gives you the probability of something happening in a given time period. Exponential gives you the time difference between each events in a Poisson distribution.
Yes, a time difference. It is going to calculate time value, right? A time difference, sir.
Yeah, exponential we use to calculate the time difference. So like in Poisson, what we are given is what we are generally asked is, so if we are given a period of time, let's say 2 hours or something, and we know the mean value and all the parameters for the Poisson distribution, what is the number of events that will occur in the given time period? Okay. For the exponential distribution, the question is like, there are Poisson events occurring. What is the time between one event and the next event?
Sir, can you explain the first problem again?
Yeah, so in Poisson, what we do is
the first problem you took, no, sir. Exercise problem.
the first problem here. Okay, yeah. Just a second. Yeah, so here the question is 60 patients visit the outpatient ward in a hospital every day. On a particular day, in the first 2.5 hours, no one came. What is the probability for that? So here we are dealing with time. That's why we are using the exponential distribution. If the question was like 60 patients visit the outpatient ward every day, given that 2.5 hours have passed, how many people have visited? What is the probability that 10 people have visited or 20 people have visited? Then we would have used a Poisson distribution. But since we are dealing with time, we are like in the first 2.5 hours, no one came. So what is the probability of this occurring? So here, first what we do is we calculate the mean time between patients. So like, given that the hospital outpatient ward is open for 8 hours and every day 60 patients come, we assume that they come at like equal amounts of time, and we get a mean value for that, which is given by 8 by 60. So this is the mean occurrence of the event. For exponential distribution, we need the rate parameter, which is the inverse of the mean. So lambda is given by 1 by mu. So we get 60 by 8 is equal to 7.5. This is the rate parameter for the exponential distribution. Then for exponential distribution, the probability that x is greater than equal to some value is given by e to the power minus lambda into that value. So what this probability is basically the probability of small x time passing between each event. At least small x time passing between each event. So we just substitute 2.5 in place of x and we arrive at this value. So that's how we solve this.
This should be 1 minus e power minus lambda x, right?
If you do 1 minus e power minus lambda x, we'll get probability of x less than 2.5.
No, it is asking x greater than 2.5, right? So
yeah, it's
it
asking
should be
x
1
greater
minus
than equal to 2.5. So for the first 2.5 hours, no one came. So the minimum time between like the next page, like the time of start and the next patient is 2.5 hours. So we need the probability of x being greater than equal to 2.5.
I didn't get it, sir. Can you repeat it, sir?
Yeah. So what you are saying is like, so probability of x less than x is given by 1 minus e to the power minus lambda x. But we need
Okay.
probability of x greater than 2.5. So we know that for the first 2.5 hours, no one came. So we know that x is at least 2.5 hours.
Yeah.
That's why we are using this. So x is at least 2.5. It can be greater than 2.5, but it cannot be less than 2.5. That's why we are not using this. Using this formula.
Okay. So usually exponential is used for continuous values.
Sorry?
Exponential distribution is used for continuous values.
Exponential distribution is used for continuous values. Yes, in a way.
Because Poisson will use discrete value.
Poisson is used for discrete, yeah. Exponential is used for continuous.
Okay, sir.
Sir, 1 minute. Sir, in the same question, e to the power of lambda to x is calculated. So lambda is minus 7.5 into x is 2.5.
Lambda is 7.5.
Correct, no, sir?
Huh.
Into x is 2.5.
Yeah.
Now, from where did we, how did we get this 7.19 into 10 to the power
So
of?
we calculate this.
How?
E raised to the power minus 7.5 into 2.5. It turns out to be, I think, e to the power minus 18.75.
Correct. 18, that I got, sir.
Yeah, that you just put in the calculator. E here is, I think, 2.87 or something. Is the constant.
We can get answer from the scientific calculator.
Sorry?
Okay.
We can get answer from scientific calculator.
Yeah, you are not expected to calculate this by hand. Yeah.
No, but just a doubt. This NPTEL scientific calculator, this e raised to the power of, as per that link that was given some days back, e raised to the power of, I can't sort of find how it is done. Just curious to know how it is, how to do that e raised to the power of. The option, I don't see it.
In scientific calculator like a Casio, first write a value upon the minus 18.75. First write 18.75, then minus, and then press E. Directly answer will display.
What I wanted was for the E option.
Sir, repeat one who explained just now. Not Arpit, sir. Somebody else explained in the scientific calculator.
Yeah, Archana, Jagdish here.
Sir, Jagdish, sir, please.
In
Repeat
the
it.
scientific calculator, if we
My
want
first
to,
mistake, sir, before you start, my first mistake is I have not yet studied, but I'm just trying to learn. I'm going to sit and study today and tomorrow. I've not gone through session 6, but please, if you don't mind, repeat it, sir.
Yeah.
No, there's only use of the
Can you
calculator.
guys see this?
Yeah.
Yeah. So what you do is like, first you type the value. We need minus 18.75, right? You get minus 18.75, and then you just press this button e to the power x. Then this gives you the value of e to the power x, e to the power minus 18.75.
Okay, so for e to the power of something, first click
First, you
on
have
that
to
value,
type that value.
type in that value, and then give the
Press this
respective
button.
sign, whatever it is, and then
Yeah.
click on exponential. Is it?
Yeah.
Okay, fine.
So what is this E is for, sir? That calculator?
Hello.
Hello, sir. In that calculator, E power X was there, no? That also
Yeah,
will
yeah.
do, that also will do good. E power
Sorry.
X is there, right? After log X here in the below.
Yeah.
Not X, EXP. This one, E power X.
EXP, let's try.
Here, down, sir. After
Yeah.
log X,
Just
10 power X.
I
After 10
think
power
this
same
X.
one.
answer will display.
No, this is just. So if you want to write
E raised to x
something in a
beside
scientific form, then you
E
use
power X.
this. So for example, if you want to write 2.1 into 10 to the power something, then you will write this. So this will be 2.1 into 10 to the power 10. So this is like writing it in scientific form. This is the exponential button, e to the power x.
Okay. So type in the value with the sign and click on exponential.
Yeah, so you just type in a value and then you just press this. This gives you e to the power whatever it is. I think all these buttons work in a similar way, right, Jagdish? E to the power x, 10 to the power x, x cube, x square, and all.
Arpit, I gone through the Casio and when I utilize e raised to x, that's also gave the same answer.
Yeah.
I am not gone through the online calculator. So give me a few
Okay.
minutes till probably proceed. I'll finding my scientific calculator. So hope
Yeah.
so both is the same thing. So I think get the same answer.
Yeah. So for all these buttons, first you type the value of x and then you press this button. Example, this is like
Because multiple scientific calculator
first
having a different mode of working. Like I have a two calculator, one is Arpit and another is Casio. Both is working in a different way.
Sir, for e raised to x, first, if you can press e raised to x and then type the value, you will get the answer.
You first press e raised to x and then click the value. Is it?
And in the bracket, put the value in the bracket, sir, if it's negative.
Sir, I want to know which are the two different types of calculator which Jagdish sir was mentioning.
I think the connection is lost or what? Some problem with the link?
Hi. Can you guys hear me?
Yes.
Yeah. Sorry, there was some internet issues. Yeah. Yeah, I was saying for all these values, first you need to type in X and then press the button. E to the power X, 10 to the power X, X square, X cube and all.
Sorry, but can you just demonstrate once more, like how e to the power of minus 7.5 could be written on this calculator?
Yeah, so first what we'll do is we'll type minus 7.5 into 2.5.
Yeah.
We get 18.75. We press equals, we get 18.75. Then we just press this button, e to the power X.
E to the power, no, you're clicking on exponential.
I'm clicking on this button here, e to the power X. Can you guys see my mouse?
I think
Cursor?
exponential and e raised to x is the same thing.
No, they are different.
Because
Sure.
I wasn't getting any answer.
Yeah, you press
No,
e
sir,
to the
I
power
got the
X.
same answer. E raised to x and exponential. Same answer I got.
Are you using the same calculator? This is the one that was posted in the here in the discussion forum.
Sir, in e raised to x, just if we first put the function e raised to x and then the value, you will get the same answer, sir.
Oh, okay, that way.
So yes, sir. Sir, first e raised to x.
E raised to X.
And then I just
Yeah, this is not. First e raised to power X.
Yes, sir.
Then
That is not correct.
it's not working.
yeah. Are you using the same
Then
one?
minus.
So this is the sequencing is different in the scientific calculator. In this, the way you mentioned is correct. First enter the number and then press e power x.
Yeah.
The exp is a different one here.
Arpit, in case you I re-verified, what are
Excellent.
the activity you did for the exp? Same answer I am getting with the e raised to x in the Casio.
The scientific calculator is exactly the other way. Press the operation and then follow with the number. Here it is exactly the opposite. You press the number and then press the operation.
Yeah. That's how
And
it
there's
works
a
for
display.
me.
There's
Yeah.
a display on top which says exponential, the number. If you press the number and then the exponential, e power x, you will have the display. What you want to see is, for example, if you say square of 2, you press 2 first and then the square. In the scientific calculator, it is exactly the opposite way. The sequencing of operation is opposite, different. The capital EXP button is the exponent, power exponent.
Yeah. That's not the exponent. That's not e raised to power X.
That is not e raised to the power x. So
Yeah.
we need some practice, but
Yeah.
it is actually quite convenient to use if we have practice. Else we will lose a lot of time in the exam.
You're sure this is the calculator you guys will get, right?
But
Yeah, then you
Arpit,
guys can start using this.
as per the question or the formula, I think e raised to x is the correct way. No doubt exponential is we find another answer to do the activity.
exponential is different. This button is different than e raised per x.
So
This is
what we should follow? E raised to x. Am I right?
it is the same thing. The way we use the calculator is
The way
different.
we use is different. Yeah. Wait, you can
Okay.
write e and then exponential of that.
The way we in the scientific calculator, normal scientific calculator, the sequencing of the way we enter e power x is different. That's about it. It is
Okay.
here it is exactly the opposite.
Thank you, Gayatri, for further clarification.
Mm,
That
you're
will help in the exam.
Yeah, we need some practice because the first time I fumbled for one exam, I lost a lot of.
Same for most of the people.
I had sent another link where we have there is a tutorial on how to use the calculator. I found that to be very helpful. She explains it quite well.
Yeah, you should
The
go by
tut-
using e raised per x. Yeah.
And it's a must that we need to spend some time practicing.
Yeah.
So in this regard, I have a request. Can you please post a sample question paper of the examination itself, so we will know how much time to practice the questions.
I have a same this thing, sir. I have the same question. Please give us some sample papers or something where we can understand what is the how is the examination going to be, and what is the time required. What all we can.
Statistics.
Okay, I'll
Yes.
try. Yeah.
Yeah, last 2 years, the examination paper set is available, then benefited to us.
So we will know how much time to allot for this one and in which areas we need to practice a little more.
Because
Without
in
practice,
routine, Arpit bhai, in routine, we are using Excels and multiple all other functions. So we are getting our answer very easily. But the
Yeah.
scenario in the exam is quite different.
I just wanted to know one
Yeah.
thing. Where is it that the tutorial on this calculator is available?
In the discussion forum.
It's there's a link, is it?
I have sent a link. You check
Yeah.
email discussion forum and you.
Can you please post it in the chat with regarding the link as to how to use the calculator?
Yeah.
Just a second.
Okay, I'm trying. I'm fumbling here. Sir, can you please do that for me?
Yeah, yeah, yeah.
Thank you.
Just post your full message.
Hello, sir.
Yeah.
In the week 5 assignment,
Yeah.
for the question that is minimum number of people, you explained, no, sir. Question 3, week 5. I got 50 as answer, and in the solution it is given as 54. I checked in Excel, and I have raised that claim on discussion forum. Still, they have not yet corrected the marks.
Just a second.
Week 5.
Week 5. Yeah.
Question 3.
We have to do this in.
You explained on that day to use Excel and check it.
Yeah.
And I got 50 as the answer because it is crossing the threshold 3.84 or 50. So in the solution, it's given as 54 in the assignment solution. And I also have raised this objection in the discussion forum. I not yet got the marks.
Did someone else also get the same answer?
I don't know. I mean, yeah, somebody has.
Yeah, I'm asking. Yeah.
The answer is at 53, you get the value below 3.84.
Question 3.
You'll have to go. The answer is 54.
Answer is?
54.
No, it's not 54.
Yeah, I'm
it's
getting
wrong.
54.
I got it as 54.
No, answer
I
is
also
wrong.
got it.
Answer is 50. I got in Excel. I can share the screen. I've done the solution. I've got 50. For 50 number of people, it is crossing the threshold. So I've raised this objection in the forum. They are not yet given the marks.
With the kind
Sir,
of
the
data,
correct answer is 54,
the correct answer is 54, sir.
Just a second. Let me.
Even other candidate has also objected.
Yeah.
Please.
So we are given these values for that question. 23, 30, 43, and 33, right?
Yes.
So here the chi-square that we calculate is 1.67. Then we just need to increase the values. We need it to be greater than 3.84. At 50, it's coming 3.04.
Where, sir?
At 50, it's coming 3.04, the chi-square value. It's not greater than 3.84.
54 is the answer actually.
51, 52, 53, 54. Yeah, 54 is the answer.
No, sir, the values are different here.
The values I have changed the values, no?
23, 30.
23, 30, 43, 33.
43, 33, right?
Yeah. So if you input 50 in place of 43, you don't get a chi-square value of greater than 3.8. You get 3.004.
I think they have some error in the adjustment minus 0.5.
Yeah,
because,
you might. Did you do
Yeah,
the
Yates
Yates
correction
correction?
without Yates correction, right?
It is with the Yates correction, right?
No, one minute.
Use Yates correction. It's
I use
mentioned in
Yates
the
correction. Yeah,
question.
with Yates correction, I got with you. If you use Yates correction, it will get 50, sir.
If you use Yates correction, it should be 54, right?
I can present it, sir. I've done in Excel.
Yeah, okay, you can share your screen.
Okay, I'll share, sir.
Sir,
Yeah.
Because with Yates correction, we'll be subtracting with minus 0.5, right? 0.5.
Yeah.
I'll present it, sir. See, sir, here. This is the present, right?
Yeah, we can't see your screen.
Just a minute. Where is the presentation? This one. I cannot present it, I think, right? But option is
Yes.
not given.
Vikrant, right?
Yeah.
Just a second. Yeah, I think now you can present.
Are you able to see, sir, now?
Not yet. Yeah, it's still not visible.
No, sir.
Yeah, okay, I think it's visible. Yeah, it's visible.
You can see that 2330. This was 43, right?
Yeah.
So I can see that this is expected value, is observed value. Expected minus observed, I got 4.11 minus 4.12 minus 4.12 4.11, and with Yates correction it is 3.61, and I squared it, I got 13.0321, and with by E. So the threshold value is 1.68, right?
Yeah. Okay.
So if I go to 49, it is 3.72, less than 3.84, right?
Just a second.
I'm getting 3.72.
I think you are doing some mistake because
For 23, 43, 66, 30, 33, 63.
these values are coming different for me.
How come, sir? Because expected minus observed value, I'm getting 4.11.
Can you show the code for that, all the expected values?
K20, I mean, I've used cells. Expected
the
minus
expected values.
Expected value. I calculated using calculator, 66 into.
That you have to calculate every time you do that, no?
Yeah, 66 into 53 by 23, right?
But if you change 49, the rows also change, the totals also change, right? So it will change
49.
all of your expected values.
Yes.
Not all, but 3 of them, I think.
Naturally, it will change here, no, sir. 49, 3.72, 50, it is 3. If I give 50 here, it will be 4.24. It is crossing 3.84.
I think there is some issue with your calculation here. Instead of doing it by hand, can you calculate the expected values and everything using
Expected
Excel?
value, we get 27.11, no, sir, for 23.
If you are changing it to 50, you won't get 27.11.
No, sir, it is this is
Just a
43,
second.
right? 66 into 53 by 23. Column sum and row sum into cell value.
The column sum is not 66 anymore, right? The column sum is more than 66. If you put 50 here instead of 43.
Yeah.
Yeah, change that 43 to 50.
Yes.
It's 73. Okay. The upper one is 53. Okay. Just a second. So the total will be 136, right?
Total will be 70 plus, 136,
136. So the first value should be 73 into 53 divided by 136, which turns out to be 28.4, not 27.1. You can do the calculation.
No, the question says other values remain changed, only the number of people.
Other values as in the other table values remain same. The total and all, everything will change. The expected values will also change.
The expected value will also change,
Yeah. The only thing that will remain constant is the only things that will remain constant are those 3 values, 23, 30, and 33. Everything else will change.
The expected value also has to change.
Yeah.
Okay. In the question, it says other values remain unchanged.
Other values as well in the question table, yeah. Not all the other values.
Okay.
Yeah.
Thank you, sir. Thank
you. Yeah.
So I have one question.
Yeah.
When do we know?
Sir, are all the week 6 questions are completed? All the week 6 questions?
Yeah. Those were the 4 questions. Yeah.
No,
Because sir, we have some other questions also.
I think there was one or two more
Sorry?
for week 6. Week 6, similar assignment. I think there were 2 more, perhaps.
Just a second. Rank sum, logarithmic concept, yeah. Yeah, can you guys see the screen?
Yes.
Yes,
Yeah, so
yes,
we discussed this. Okay, this one we did
yes.
not discuss anything similar to this.
Second one, yes.
Which design? So yeah, this is kind of straightforward here. You just need to calculate the reliability, which is like the formula for which is given. You are given the shape and scale parameters for the variable distributions. And then you just find out which one of them has higher reliability. It's kind of straightforward. Then these all we discussed similar. And this one also we discussed similar questions.
So the last one.
Last one, I can't really answer that, right? You guys have to think what all you can use here. If you
Okay,
go
sir.
through the video, you can find it. It's a direct question, yeah.
Sir, for the second one, can you please take any arbitrary value and can we do that?
Just a second. Yeah, I'll find a question. Meanwhile, if anyone else has any other questions.
I have one question, sir, regarding that
Yeah.
problem on AIDS correction.
Yeah.
So, in manner we try to find the what is the number of successful drug values. Like we
Yeah.
increased 43 to 54, we can do the
Yeah.
same thing for the placebo, for the upper right corner. I can change the different values in different columns and rows, right?
Yeah, but in the question you are just asked to change the bottom left value.
Yeah, I that is there, but I can also do this for the placebo. Similar exercise. What is the
Yeah.
successful number of what is the successful number that is required for the placebo? I can do that, right?
You can do that, but it does not make any sense
Right.
really.
But
Because
what
the placebo is not supposed to work. Yeah.
if I do at what value, I can do the same thing for the second row, second column, which is the drug did not lower. For the, I can change the number from 33 to some number. I can keep
For
increasing.
the drug and did not lower. Yeah.
So that and the placebo lowered blood urea value should be the they should be in sync, right?
Need not be.
The placebo being successful is drug being a failure.
No.
No.
They are not related. Placebo is a different thing. Drug is a different thing.
For this
The
particular.
success. Yeah, the success rate of placebo and drug do not depend on each other.
They do not depend on each other, but I can do a calculation where I just increase the placebo.
Okay.
And I will get at It doesn't make sense, but I can mathematically do the calculation.
Yeah, you can mathematically do the calculation, but it does not make any biological sense.
At, mm, and so that will also mean if I say the placebo is successful, it also means that the drug is not good, the value is not going to be at
The
that
drug,
number.
sorry.
For that particular so for that particular value, so
Yeah.
for at that particular value where that placebo is successful, the corresponding drug value is not good enough, right? To show
Yeah.
it is successful. That is what
Yeah.
it means.
Yeah.
So I'll have to get a particular value for that particular data set. At where
Yeah.
Okay.
So for example, like if you are keeping everything constant and you increase this value, the placebo and lowered blood urea level, you will see that the chi-square was 1.6, it became 1.4. So if we increase this cell, the chi-square value slowly drops. So to prove that the drug is effective, you will need much more than 54 samples. So now it won't work with 54. Needs more.
So
Yeah.
what I'm saying is, if the first column, the first row and the
Yeah.
first column, and
Yeah.
second row, second column, we should see some correlation, right? Because this is drug failure.
Some correlation as in, yeah. So what happens is if you increase this value or this value, keeping everything else constant, the chi-square will decrease. But if you increase this value or this value, keeping everything else constant, the chi-square will increase.
So what I'm trying to say is there a correlation between these two calculations? So what I'm trying to say is the first row and the first column.
Yeah, there is some correlation between both, right?
Second row and
because the placebo lowering blood urea and the drug not lowering blood urea basically gives us something similar.
Something
You
similar.
can't say one is caused by the other, but there is some kind of relation.
And then
Relation won't be a good word, but yeah.
The first row, second column, and the second row, first column. So placebo.
They also have similar correlation here.
So is there a specific? I mean, a specific formula to connect these two?
I don't think there is some specific formula. You can derive a formula, but that will be quite, it will be some quadratic formula maybe. Because the chi-square formula that you are using takes into account all of these values, right? These two values positively affected, these two values negatively affected. That's all.
What I'm basically trying to say is the drug, if I do an experiment, and then I have the drug at 54, then it crosses the table value and I can say that is a minimum. Or I can do an experiment where I have the placebo for the same number of 43 people and I give a placebo and I change the did not lower value. So for the value 43, I get the placebo being increased.
Yeah, you can do the same, but it will be very hard to biologically explain why you went that way instead of this way. It will give you the same result statistically. Like if the placebo in lots of cases did not lower blood urea, but the drug in some cases lowered blood urea, then of course the drug will be significantly better than the placebo. But if you suggest this to some committee or you try to like get your drug approved, they'll question why didn't you increase the testing of your drug instead? Why did you increase the testing of your placebo? So this is kind of one of the ways in which you can like use statistics to kind of manipulate things. This is not a
But
good thing, really. So there are other things like p-value hacking and stuff like that that people use to get a statistically significant result when there is no statistically significant result. So this is basically something similar to that.
I think there's something called the placebo effect itself, which sort of adds to the background. And um, I mean, the question as to why did you increase the number of trials of placebo instead of drug becomes a valid question.
Yeah. Statistically, both of them will achieve the same result, but if you are doing some biological experiment, you can't really justify this or like give a proper logic of why you went that way.
okay. Okay. Or maybe if it is a high risk drug, then I do not find enough participants. Then maybe increasing the placebo.
Even in that case, increasing the placebo will not be considered a good thing.
Generally, in pharmaceuticals, both the samples, like saying placebo and drugs are similar, and randomized technique is most prevailing in the industry. This is for the research or understanding purpose. I think this question is raised by the tutor. What I understand.
Yeah.
Because all the streams have their own standards, and we cannot disobey that guidance.
Yeah.
So, but if you look at the total, usually the placebo number of people and the drug number of people are the same. But here it is coming to be different where the drug is a success. So I can have the data manipulated in such a manner where the drug is a success, right?
Yeah. Since we are learning about statistics and we are just calculating questions, it's easy to do these manipulations. We can like for our curiosity to see what happens when we change a single value. But in real world, you can't do these things.
Okay, okay. Okay.
Sir, in week 6 assignment.
Yeah.
Sir, can you please go to the questions?
Go to the questions. Yeah.
So how will submit answer for one? Like we cannot multiply and put the value 10 raised to -9 or whatever the answer comes of the first one. So up to how much decimal point we can go for?
It's not mentioned here, and I think 2 or 3 should be enough.
So, but that would be probably all would be 0, 0.
Probably, yeah.
Sir, also
Arpit,
for
I
question
got the
number.
different answer actually through Excel. So I need to check first my own answer. Because this functionality available in the Excel sign, I utilize that for my understanding purpose.
Okay.
So, and also for question number 5.
Yeah.
So, at probability 0.05, there is evidence to suggest that. So, sir, should we means for this now? I'm not understanding how to proceed for this question.
So you got the rank sum for both of them, right?
Correct. Yes.
Yeah. Then you need to see which is the lower rank sum, and then you have a table.
Okay. That
You
I
just
got.
need to check
Understood.
the value.
Okay, the last question you gave. Okay, sir. And also, sir, for question number 5, they are asking to round off the answer up to 1 decimal point. So if I'm getting any particular value, then should I put 0.0?
That would be safer.
Okay, sir. Understood. Yeah, thank you, sir.
So, this question number 1, actually, I think they might have, because while I was going through the video also, one of the questions they have solved, they just, instead of, so here what we did was calculate that the mean, and we got lambda as 1 by mean. So in one of the questions, I think somewhere in a video or in one of the past years papers, what they did was just took the lambda, like took this as the lambda and not the mean, which should not, which is not correct is what I feel. That's why I had calculated it this way, but I think if you calculate it the other way, you might get a different answer. So I'll discuss with the other T. Anyways, you have to submit it after his class, right? When is the submission? 8.
Yeah, 8.
Yeah, I'll just talk to him. We'll, and then like you can calculate the answer for question number 1 based on whatever he says. Because I'm also a bit confused, but I found that this is the way to go. Because generally, everywhere else, what they do is they get the mean, then they calculate the lambda value from the mean. But I think in one of the questions somewhere, sir did not do that. He just used this value as the lambda. That also makes no sense because like, then you don't get a ratio, you don't get a probability value, right? For example,
Yes, sir.
like if you, yeah, in this case, what you do, you get the units of lambda here will be 1 by r. And if you multiply it by r, the units will cut off and you'll get a probability value. But if you just take this as your lambda and you multiply it by an r value, then the units won't be like, the units won't get away. You won't get a probability value, you will get something else, is what I feel. So last year also, I think they have solved it in a similar way by taking this as lambda, the mean time as lambda instead of mu. This they took as lambda. So they got a different answer, but that question was also marked for evaluation. So I think this is the correct way to go. But anyways, I'll talk with the other TA and like he can guide you better on this.
Sure, sir.
Is that okay? Yeah.
Yes, yes.
Yeah, Arpit, can you please provide some hint on the second questions, taking the another example or similar hypothetical questions?
Yeah, just a second. The question, shape and scale parameters are given us. So let's say we have two designs. The shape parameter is given as 5 and 90,000. Shape and scale. Shape, scale. And for this one, the shape and scale parameter are given as 6 and 100,000. Which design is more reliable? So for calculating the reliability for the Weibull function, we just have a formula. Reliability is given by e to the power minus is to the power beta. We just substitute these values here. Right. So this shape parameter is beta. The scale parameter is eta. Gamma we take as 0 threshold value if it's not given. And we just calculate the reliability here for A. Just a second. The question is, which design is more reliable? Other thing you can do is you can get the failure rate. This is also okay, no?
So what is t value here?
T is the time. So as
No.
time increases, the reliability, does it increase or does it decrease?
Yeah. Time, what we can take?
You can take any random time values, right? So you can just plot these two functions and see which one of them is. So for example, if you plot this one and plot the other one, RA and RB, if you find that with time, both of these values, like one of them has a lower value than the other, then this one will be more reliable. But if you find the other one, then the other one will be more reliable. That's one
Time
way
I
to
can
go
take any
about it.
value, sir.
You can just plot from 0 to whatever value, the scale value. Let's say from 0 to 100,000. Plot all the values. Or you can just take the ratio of both of these and see if it's greater than 1 or less than 1.
Thanks for clarification.
Another thing you can do is you can get the failure rate and see which one has a greater failure rate.
So, how to interpret the graph? Can you please repeat?
Yeah, so one way to go about it is like, so you'll plot the reliability of A and reliability of B with increasing T. So this is T and this is reliability.
Yes.
So the graph which has a higher value of reliability, which will be more reliable. So instead of plotting the whole thing, you can see at a specific point, let's say 50,000 cycles, 50,000 whatever, or like 60,000 whatever, the difference between both these values, which one is greater? So the one with the greater value will be more reliable. I put it as 100,000 and we take T is equal to 100,000. The reliability of A at minus 5 and reliability of B at E raised to power minus 6. So since this value will be therefore this will be more reliable. For ease of calculation, I did it. So if we take the scale for both of them to 100,000.
Scale value for 5, right?
Sorry?
You change the scale value for 5. Both won't be 100,000.
I didn't get that. Sorry.
For A and B, I think
Yeah.
shape and scale, you had changed the value for scale in the case of A, right?
Yeah, I
Uh,
changed the value. So for easily calculating. Yeah.
Yeah.
If
So
you keep it at
here,
90,000, then yeah, you might
so
get a
here
different thing.
our A within brackets won't be 100,000, right? Huh? Both you have kept as.
Yeah,
both you
so
have
what
kept
I'm
as
doing
100.
is, so in the question you are given the shape and the scale values. Okay, let's say you are given the shape value of 5 and scale value of 100,000, shape value of 6 and scale value of 100,000.
Okay.
Then you have a reliability function which is given by this. So the shape thing is beta, the scale thing is eta, and gamma here is 0. It's just a two parameter Weibull distribution.
Okay.
So for A, the substituting beta and eta, you get the equation, this one. For B, you get this equation. Then at some random point, so I took both of them as 100,000 so that I can put 100,000 here. So,
okay.
but
Okay.
yeah, you at some random point at some random large point, you can put substitute the value of T. So for here, I did it 100,000. You can do it whatever you want. And then you get the value here of reliability, and you check which one is more reliable, which of these values is greater. So here A will be more reliable because this will be greater than this. Right.
Weibull distribution. I've just started it. I haven't gone too much into it, so that I mean, I haven't gone through the basics of it yet. The others, Manvites and Wilcoxon, I'm familiar with. So I was just curious to know now the relationship between these. I mean, I'd have to go through the lecture, but just the concept
The relationship
between the different parameters. I was just.
Okay, so I don't think there's a relationship between different parameters. So like the beta is the shape thing, the shape parameter. So what it does is change the shape of the Weibull distribution. So depending on the value of beta, the distribution can look something like this. It can look something like this, or it can look something like this.
Okay.
So for beta is equal to 3, I think it looks like a normal distribution. For beta less than 1, it looks, yeah, I'm sorry, I kind of don't remember this.
Okay, it becomes more skewed, like.
Yeah. So yeah, based on the beta, the shape changes. For eta, what happens is, if you have a lower eta, then it looks like this. But as you increase the eta, it becomes flatter and it extends. So as eta increases, this happens. And gamma is basically the intercept kind of. So if one distribution with gamma of 0 is like this, then the same distribution with the same parameters and gamma of 20 will start at 20. So it just shifts it to the right.
Sir,
Yeah. Yeah, continue.
Sir, could you please explain how to answer question number 5 again?
Question number
5. In the 6th week assignment.
6th week assignment. Just a second. Question number 5. Yeah, so you got the rank sum for class 10A, you got the rank sum for class 10B, right? For question number 3 and 4. then all you need to do is you need to check out which rank sum is the lower value. You need to go to the table for Mann-Whitney or Wilcoxon rank sum test, whichever you are doing. You need to go to the table and check if the value of the lower rank sum is less than the critical value. If it's less than or equal to the critical value, you reject the null hypothesis. Otherwise, you accept the null hypothesis.
Okay, sir. Thank you.
Yeah.
Sir, we have to use both the test, Mann-Whitney and both are same, no? Wilcoxon and Mann.
No, you can use either one.
Either one of them.
Yeah, you'll get the same values, and I think you'll get the same answer for 5 also. You should. Because anyways, calculating the rank sum in both of them are like similar. Basically the same process. Just the values of T, I think, and the statistic are different.
Sir, why do we use median rank in Weibull distribution for calculating failure rate?
Sorry?
Why do we use median rank log of log? We're going to linearize the equation. That's what I've gone through video.
For the Weibull
For calculating
distribution.
failure rate.
Yeah, so in that question, what was given was you were given some values. You were not given the shape and the scale parameters, right? You needed to calculate the shape and scale parameters. So using the Weibull function, you just take log twice. So you get a linear thing. And then you can plot that function to fit a curve through it and get the slope and the intercept, which will give you the shape and the scale parameters. We linearize that because it's easier to fit a linear line through data than fitting a log or anything else. Make exponential through the data.
So especially is used for failure rate. Huh?
Yeah, so for after we get the shape and the scale variables, we can put it in the failure rate to calculate the failure rate. For example, in the question that you are given currently, you are just directly given the shape and the scale parameters, right? If instead you were given some values instead of the shape and the scale parameter, you first would have to estimate the shape and the scale parameters for biomaterial A and biomaterial B, and then use those values to calculate the reliability here. It's basically the same thing that they're doing with failure rate in the video.
What is the accuracy, sir? Because failure rate is okay. How do we check the accuracy of failure rate?
Accuracy of failure rate as in?
Hello?
Yeah, I didn't understand what you mean by accuracy of failure rate.
No, because failure rate, how far it deviates from the true value with respect to it's going to see. We are not going to take any variance. Usually, when we take the in the
No, here we are not taking
other
anything
test
like that. Yeah.
In the other test, we are going to test for means, test for variance.
There, yeah, here also there will be some variance, but we are not going into that. We just assume that the failure rate that we get by fitting.
If you want to detect some material or drug,
yeah,
what is the how far it's going to fail over a period of time?
Yeah.
Is it that whatever we get through Weibull distribution is how far it is accurate? Whether it's 90% accurate? Is there any true value for that?
There is no true value for that as such.
If I take a vehicle, if it down the line 10 years, if it's going to fail, the life
Yeah.
of the vehicle will be 10 years. But if I use some observations and calculate, it's going to come as 13 or 15.
Yeah,
Are we
so that's why
measuring
you
that?
use as much observations as you can, because you can't get the population value at some things might work for quite a long time. Some things will might work for quite short time. There's no probability thing that we are doing here for the Weibull distribution. We are just fitting a line through it, and we are assuming that whatever we get is the population distribution. Like
Is
because it gets
it's an
very
inferential
complicated.
statistics or what, sir? It's an inference to the population.
Yeah, it gets more complicated. That's why we don't deal with that part for the purpose of this
Because
course. I am not sure whether
we're
what
only
they do
taking
in the
samples
industry
and
and all.
calculating failure rate,
But
right?
yeah, here that is all we are doing.
Are we inferring whether it's also for population?
No, we are not.
Is there any advanced statistical methods for that? I mean, I don't know about that. I mean,
I am not sure.
because if they want to test for drug failure rate
Yeah.
for a period of 5 years, 10 years, is that take threshold for they infer for the whole population or only for that sample?
See, as for every distribution, the Weibull distribution also has variance and other things. I think you can use that to calculate whatever you need for the population. But for the purposes of this course, we won't get into that.
Okay.
I just wanted to point out one thing. There was a question, I think, about the question similar to question number 1 in assignment 6 about the decimal point problem. That is, now the answer that we got in the sample question was 7.19 into 10 to the power of minus 9. And in the sample problem, it was specified round off to 3 decimal digits.
Yeah.
But then
So
that's in the
as I
actual
said, the answer. Yeah,
Huh.
continue. Sorry.
Actually, in the assignment, that specification is not there that we should round off to 3 decimal digits. So I find that we can enter the answer even to beyond the number of, even beyond 3 decimal digits, we can enter. Only thing it is not possible to enter like 7.19 into 10 to the power of whatever, like that we
Yeah,
can enter. So
as
there's
I
no
said,
problem.
as I said, the way I explain the answer is kind of what you should do, but I think in the course they have done something very different. So instead of treating this as the mean, they have treated this as
No,
the
I
rate
didn't mean that.
parameter.
I didn't mean
Yeah.
that question. I didn't mean that.
So yeah, that I'll discuss with the TA, and then you guys can decide in the next class what to do.
Sorry, I didn't mean that part of the question. What I meant was that there is no restriction now on the 3 decimal digits. As per the present assignment, there's no restriction on rounding off. It's not mentioned as part of the question, so we can write the full answer. I mean, like even if
can, I guess, yeah,
even if it is 0.000, whatever numbers come after that, we can still write it. Only thing you can't express it as into 10 to the power of minus so much. Suppose the answer is, let's say, 0.0007. Let's say that's the answer. I can write it as 0.0007, but I can't,
you can't write it scientifically.
7 into 10 to the power of minus 4 or minus 5 or whatever. Like that, I can't write.
Yeah, so as someone was asking, I think the Weibull distribution is a specific, what do you say? Specific case of the gamma distribution. I don't think they talked much about the gamma distribution, but I think you can use the gamma distribution for other advanced kind of statistics that you want to do. But I don't think for the purposes of the course, we will get into that.
Hello, sir.
Yeah.
Sir, when the recorded videos are uploaded, sir?
It will be uploaded tonight.
Okay, sir. Thank you, sir.
Yeah. Okay. If there is no more question, we'll stop here and we'll meet next week. For question number 1, you can refer to the next class that the other TA will take.
Yeah, thank you, Arpit, for a nice discussion. And if possible, if we can get past year's questioners in the exam, then that will be benefit to us. Because we tried on the internet, but no such history is available.
Yeah, we don't have exam papers. Yeah, that's what. We don't generally provide the question papers online. I'll try to find, if I find anything, I can share it with you guys, but I'm not sure.
Also, there's
Is
no
that okay?
update. Also, there's no update on that assignment 3, that question where some of us have written 1.65 and 6.
Yeah, I have still not heard back from them yet.
Because I carried 3 points and, because it was like decimal thing.
Yeah,
Sir,
I still
tentatively,
not
when do
heard
we
back
get
from
the ticket, hall ticket confirmation or venue?
I'm not sure, probably a week before the exam or something.
Because we need to book tickets if it's like Bombay or the second or the third option, which is away from.
You can post on the discussion forum. Those guys will reply to it.
Okay,
I
sir.
am not right. We are not kind of dealing with the logistics, so we are not sure. Yeah.
No
Yeah,
problem.
Archana, you're raising your hands. Yeah, thanks. Do you have anything, any doubts?
Rachanaji, question is for you.
Okay. Okay. So we'll meet next week. I'll upload the video by tonight and update it in the sheet, Google Sheet that you guys have.
Okay, thank you.
So we'll meet next week. Yeah. Chalo. Bye.
Thank you, sir.